Inside a 6th century BC burial mound in Germany known as the Hohmichele tumulus, archaeologists uncovered the remains of an elite local ruler. Among the grave goods was a single, decayed textile fragment. Woven into that fabric was a single thread of silk. This created a chronological anomaly. Silk comes from China, and this tomb predated the official Han Dynasty Silk Road by hundreds of years. To the naked eye, there is no way to determine who brought it across the Eurasian continent or exactly where it was made. To find the origin, researchers used biochemical analysis. By breaking down the silk proteins, they could measure the exact ratio of amino acids that form the microscopic fiber. This comparison shows the structural difference between two types of silk. On one side is the amino acid ratio of domesticated Bombyx mori silk, cultivated in Chinese imperial workshops. On the other is the distinct molecular chain of wild silk. The thread in the German tomb matched this wild silk signature. This reveals it was transported by mobile horse nomads operating across the central steppes long before imperial routes were established. Looking through a microscope reveals an invisible, ancient shadow economy, a network run by nomadic tribes that bridged the east and west centuries before the first official trade maps were drawn. Expanding our view from microscopic fibers to the objects people held in their hands takes us to the vast steppes of Mongolia. Here, inside the burial mounds of the Xiongnu people at AlUla, another anomaly was discovered. Deep within this rival nomadic territory, archaeologists found high-quality lacquerware cups manufactured by the Han Dynasty. We identify this trade by analyzing the specific patterns on these fragments. Bold red geometric designs and spirals indicate mass production. These rapid brushstrokes show these cups reached the nomads through private frontier trade rather than as official imperial gifts. These physical artifacts prove nomadic tribes acted as discerning consumers, driving a complex international commercial market that spanned thousands of miles. To see how these markets crossed continents, we look to a physical choke point on the ancient caravan routes, the old town of AlUla. At first glance, these dense mud brick ruins on the Arabian Peninsula appear to be an isolated desert settlement. However, the material culture found buried here contradicts the town's appearance of isolation, beginning with the foreign currency used by its inhabitants. Researchers discovered pendants made from Maria Theresa thalers, 18th century Austrian silver coins found deep in the Arabian sands. They also uncovered Mediterranean deer antlers, proving that biological materials from greener, distant climates regularly flowed through this desert network. AlUla functioned as a multi-continental logistics hub where European wealth and foreign biology converged. To see the full impact of human engineering on these harsh environments, we must move from ground-level artifacts to the orbital scale. In Yemen, the Marib Dam was rebuilt in the 1980s to restore an ancient water system and revive agricultural production in the desert. Scientists track the success of this irrigation from space using a technology called the Normalized Difference Vegetation Index, or NDVI. This split screen shows how NDVI calculates health. Healthy crops absorb red light and reflect near-infrared waves, which the system translates into a green data pixel. While initial tracking showed a steady rise in production, the data shows that agricultural output plummeted in the mid-1990s. This failure was caused by massive algae blooms. Poor maintenance allowed the algae to choke the dam's irrigation canals, preventing water from reaching the crops. To solve the crisis, researchers introduced a new biological element, the Nile tilapia. As the tilapia consumed the algae and cleared the canals, the satellite pixels turned green again, signaling a restored ecosystem. Only from an orbital perspective can we track the full life cycle of massive human engineering, of cascading systemic failure, and of biological recovery. This journey connects the microscopic amino acid, the handheld lacquer cup, and the satellite pixel. These distinct technological lenses reveal connections that weren't recorded in the text of the time, mapping a level of movement that happened outside official borders. Humanity has functioned as a complex, interconnected system of environmental engineering, global trade, and cultural exchange for thousands of years. Modern technology provides the resolution needed to see the past with clarity. It connects the microscopic and the orbital to reveal humanity's true global scale.